Hello everyone, my name is Hans Bernhardt and
I'm Simon Hamilton Wilkes.
And we're here with Mark the Caveman to present to you MultiCloud for your Caveman. So, as an introduction, as we know, MultiCloud is the new normal. And just like clouds in the sky that have many different characteristics, we are quite aware of the fact that the clouds that we use in our compute world are also quite different and have many different characteristics.
So we have this complicated world where every cloud has different intrinsic properties, and there's no way to transfer stuff between them at all easily. Pat sort of called out this morning that 97% of organizations are planning multi-cloud for their mission-critical apps. 70% foresee the ideal end state being multi-cloud. So there's this thing where rather than just this simple migration from on-premises to the cloud, there's lots of clouds, and on-premises has become a cloud as well, as VMware likes to preach with the whole SDDC. So those migration and mobility challenges, mobility in the sense of the mobility of applications and VMs. Everything's incompatible. They're all running on these different stacks from different vendors and developed over different timescales. There's all the different networking and security bits where the underlying IP address network is different, so it's very basic, up to more complicated things such as instantiating security policy and making sure that workloads are equally secure in one site or another one. And then there's application dependencies, and where applications are dependent on multiple components for the application, or where the application is dependent on an external thing, like a big data repository or a whole bunch of other things. And then all that leads to disruption, because instead of being able to migrate workloads transparently, you have to take an outage and figure out how to get them from A to B and translate whatever you need to translate in the process.
So what this comes down to is we have all these, we'll call them disparate clouds that we have to work with, and our caveman says, cloud big, many, must move workloads. And that's fundamentally our goal, to be able to move any workload, whether it be a virtual machine or containers or pieces of apps, vApps, which would be virtual machines in different clouds actually working together across clouds. So our caveman is getting smart, and he starts thinking about it. Now that I think about it, I really am interested in making all these clouds work together, but I gotta note that the underlying plumbing is pretty complex. It would be great if it seemed like it was all unified, like in one single pipe. And speaking of pipes, well, not really a pipe, but let's start with VMware as the company to deliver multi-cloud, and look at what looks like this big pipe here. And Simon and I went back and forth on this because this is actually rock stick candy. So Simon, if you would explain this metaphor.
All right, so to explain from an American who calls it rock stick candy, which makes no sense to me, this is called a stick of rock. And there's places in England, specifically Blackpool, but other places that sell this type of candy, which is a solid sugar thing like a candy cane you'd have here on a Christmas tree. But the neat thing is in the manufacturing, they put the same text all the way through. So as you eat it, you reveal the same text all the way through.
But in this case, the metaphor is not the same text all the way through, as you can see. It's actually the same cloud abstraction layer that goes through the entire rock stick candy. So there's your metaphor, and of course, Caveman Mark says, forget pipe, consume candy. Abstraction is good. Shall we start at the bottom?
So the whole origination of VMware is abstraction. So back in the day, when Hans started at VMware,
19 years ago,
the hypervisor came and you were abstracting from the hardware, and then as time has gone on, there's been abstraction from the networking layer, and abstraction from this, and abstraction from that, as we've put more automation layers in and other stuff. So we're now trying to figure out what extra abstraction we can get in order to do the same thing that abstraction is accomplished everywhere else, where it's made this, it's become this buffer to enable flexibility.
Basically, but here's the deal. We have this abstraction from physical to hypervisor to data center to cloud, but every time we abstract, I'm sorry, I need to speak like a caveman. Every time we abstract, we add a cool new layer of functionality, which automates and simplifies at one layer, but then adds another layer of manual tasks. Those tasks then need automation. It's a simple reality as a cloud matures and can get complex. Now, restated, the way I like to say it, and the caveman will say it, is when you add a layer of automation, it adds another layer of cool things you can do, but it also adds another layer of manual things you can do. So restated, it's manual, automatic, automatic, manual, manual, automatic, automatic, manual, manual, automatic. I see heads nodding out there. Bingo. So we're at the point where we need to put an abstraction layer up above all of these clouds, and we need help at our existing and the new layers. And
so integration is sort of the key thing. So having this abstraction layer, integrating all these different component parts to enable that workload mobility without having this huge short list of manual steps that you have to go through. Because it's no good being able to accomplish this if the way to accomplish it is a 30-step process for every VM migration.
And Caveman says, layers, integrate, yummy. So what it comes down to is HDX is going to be the icing on the multi-cloud cake. And of course, Caveman says, good, hungry, consume clouds. HDX is going to be that abstraction layer above all of these clouds. And this is where I hand over to Simon.
So HDX has got all these great features, and we're going to gradually delve into a few of them. But the basic idea is to be this layer that is able to migrate workloads between different clouds and different on-premises environments too, and fudge the differences enough that the workload is moved in like a online migration vMotion type way, even though there's a lot more going on behind the scenes. Because you might be going between disparate vSphere versions at least, if not going from one completely different environment to another. And in so doing, you can fudge all kinds of other things, like you can have like a single VM-based enhanced vMotion compatibility flag, and all these different things that they've built into the product to facilitate this sort of interworking that previously was infeasible. So previously we'd have to cold migrate a workload, and that would be the only way to do it. And even if you could cold migrate it, you might have to put it through a transformation process as well. HDX does it all online, which is pretty neat stuff.
Cool. Oh, is that basically the same thing? Whoop. Okay. So I will leave that up to you.
In order to accomplish this, HDX does all this stuff. And this is where HDX was 3 weeks ago prior to the most recent release. And HDX is on a kind of continuous release schedule where they push new builds every 6 weeks or so, and they just show up in the release notes. And I'm constantly hitting F5 on the release notes to see what new stuff has come. But the cool thing here is you can kind of start to see the problems that HDX is solving, because it's in order to retain the IP addressing between environments, it's doing layer 2 stretch. In order to do redundancy and bandwidth management, it's doing WAN optimization. And all this stuff is happening in the various virtual appliances. And then the new stuff in the enterprise SKU, which just launched a few weeks ago, is non-vSphere migration. So this is operating system agent enhanced vMotion or migration, where we're installing an agent into a virtual machine which is running on a non-vSphere environment, so KVM and Hyper-V right now, more presumably to come. Large-scale migration, so where previously you could do large-scale migrations and you could script them, that stuff has been enhanced even further, and it's using vSphere replication usually to pre-stage the bits as much as possible in the destination environment, so it's not having to send them all down the wire at the time of the migration. And then HDX already had basic DR, and it had a nice, very simple interface where you could right-click on a VM and say, protect this VM, and it would set up the vSphere replication in the back end and make sure everything was plumbed correctly, and you'd have a basic recovery plan for a handful of VMs. But it was really just for a handful of VMs, and it didn't have the sort of enhanced scripting for recovery plans that you have in SRM, where you can change DNS and go off to various other resources and make sure other stuff is reconfigured to point at the new destination of the VMs in a more optimal way. So that integration with SRM has been added.
So now that I know that I can move my virtual machines around between multiple clouds with this HDX thing, how do I hook all this stuff up? Ooh, this is where I get to talk, because I like to be a virtual plumber. I'm going to simplify this. I like to take things down to the root nugget of what we do here, as opposed to getting into all the bits, bytes, and feeds. So HDX is simply an abstraction layer above our clouds. Now let's think about it for a second. An abstraction layer above a physical server is a hypervisor, and that abstracts us from the physical resources to the virtual resources. And then we can stick agents inside the hypervisor, and we can also use management appliances to combine multiple hypervisors into a private cloud, and you think of that as an abstraction layer above our hypervisors to give us private cloud. But now we have all these different clouds, and we don't have the ability to say, hey, give us the same hypervisor across all these clouds or agents in those hypervisors. But what we do have the ability to do is stick appliances, virtual appliances in our environments to meet key cloud functions to tie all of these clouds together and act as an abstraction layer above them. So we have to be able to manage, one of these functions is we have to be able to manage this entire environment. The second thing is we have to be able to connect all of these clouds. The third thing is we have to be able to optimize a connection. We have to be able to keep some kind of high-speed networking going between all of these clouds. And then we want to be able to extend networks between the clouds, our existing networks that our virtual machines are on. And then Simon mentioned the OS agents for virtual machines to move around. There's different ways to move our virtual machines around, but the bottom line is when we move a virtual machine from one cloud to another on those extended networks, we want them to keep their same IP addresses. We want them to keep their same functional characteristics for our applications. So take it a step further, these are the actual virtual appliances, the names of the actual virtual appliances that meet these functions. The HDX Enterprise Manager and Cloud Manager to manage the entire environment, the Interconnection Appliance, the WAN Optimization Appliance, and then you have the HDX Network Extension Virtual Appliance, and then you finally have the HDX Sentinel Gateway Appliance, which again works with virtual machines that have agents inside of them to be able to move virtual machines that way. So that's the simplistic way of describing HDX as an abstraction layer above these different environments, these different clouds. And of course, Caveman says, oh, I see many clouds, virtual appliance to manage and connect between clouds. Optimize a connection, extend layer 2 networks, and then connect to and move VMs between clouds. Yummy clouds. And this is where Simon will go into greater detail about some of the capabilities here.
And I want to make clear that though this starts to look really complicated because there's so many VMs and virtual appliances involved in HDX, they're actually very straightforward to deploy and configure. And it's all a fairly automated process once you've deployed the initial manager, the HDX Manager or Cloud Manager as it's called when it's in the cloud. So you deploy the multi-site system software, which is deploying the manager and then going within the manager and saying, deploy me a WAN optimization appliance here and one there. And then the various appliances, some are per different configuration boundaries. So the network extension appliance is per distributed virtual switch, for example. The WAN optimization appliance is per pair of sites. So if you're setting up a ring, like we saw in the earlier diagram, each site would have a WAN optimization point appliance for one traversal to one cloud and another one to another cloud, etc. So those are the interconnects. extend the networks. So again, that's a network extension appliance, which goes across the whole distributed switch. And then in this case, this is a migration off KVM or Hyper-V. So this is where we use the Sentinel agent installed into the operating system to do an operating system assisted migration. So because the hypervisor isn't vSphere, we don't have vSphere to do a migration, to do a vMotion. So therefore we have to do it another way. And the other way in this case is to use an agent, because the only other way would be to power the machine off and then use like vSphere converter to do the biz. And then you can migrate VMs from KVM and Hyper-V into vSphere live, which is a pretty cool trick. Disaster recovery as a service. So again, this is an enhancement that's recent as part of the enterprise SKU, which was just released a few weeks ago. The automation capabilities of SRM with the existing stuff in HDX for the most part. And the cool thing is then you get the powerful runbooks that you could do in SRM to go off and do things like change load balancing rules and change usually external facing DNS. So HDX is really good in terms of when it does network extension, it can do local egress. So the traffic, once the VM has migrated from site A to site B, will egress at the local point, which is great because it's better than hairpinning it all back down the WAN optimized link. But somehow the new connections have to get to the workload. So that's where being able to change DNS entries and stuff is a good thing. I think that's all there is to say on that.
Aha!
And then the future, so with the big disclaimer that we're not PMs, we're not within the HDX team, we're not talking futures, we're purely being
Speculative.
futurists, fantasists.
Imagine if.
But wouldn't it be cool if VMware's huge portfolio, which has increased in the past several months even more appropriately, everything's API driven, if you could orchestrate taking cloud health alerts or the cost comparisons of different clouds and plugging that into HDX to do workload migrations auto-magically, and then concurrently changing load balancing rules and distributed load balancing and AVI networks, you could do some really cool stuff. And you could have workloads that migrate from cloud to cloud according to cost or availability constraints, or according to the characteristics of those particular clouds. So you could say, oh, I need to have access to this gigantic S3 bucket. Let's migrate that workload into Amazon for the moment, or VMC on AWS, because we want the proximity to a huge S3 bucket. And then, now we need tons of AI compute power. Let's migrate that into the Google Cloud, where we have better access to raw GPU power.
And that's where, when Simon was talking about this, I was like, oh, this is so cool, because this is where you start to realize, when you start to think about the layers and how we keep building and building and building, you go from hypervisor to multiple hypervisors connected by some manager to multiple different clouds, and now we're up here putting a layer above all that, private and public clouds. Well, back in the vSphere days alone, you had, great, now we can do distributed resource scheduling where we're managing at the private cloud level resources and moving virtual machines around automatically. Then we got into, hey, DPM, distributed power management in vSphere. Well, now we're surmising that at a higher level, and again, we're not PMs and have no inside info, but we're surmising that as we add this HDX level, allowing virtual machines to move around amongst clouds, that AI will be added to that with things like cloud health, AVI, and whatever else, to be moving virtual machines around intelligently, from a cost perspective, from a resource perspective, from a networking perspective, and so on and so forth.
Yeah, the workload, the use cases just proliferate the more beers you drink. But there's an infinite number, and you think, you could park workloads in low cost, on-premises, low performance silos when you're not using them, and then particularly for workloads that are seasonal in nature, and then you could roll them out to a high performance environment later or wherever. I mean, there's all kinds of
Cool stuff.
Cool stuff, exactly.
I should have, I'm sorry, the caveman's not in there saying cool stuff. My bad, I should have put the animation in there. So, more stuff, or more, how do I learn more?
Obviously, the HDX site. I wrote a white paper on this for the partner that I work at. After 5 years at VMware, being at a partner gives me the freedom to write things in white papers that I could never get past VMware Legal when I wrote white papers working for VMware, which is kind of cool. So,
and last but not least, well, definitely go try the hands-on labs. We want to make sure that you get some hands-on there. And whoa, that's it. Thank you. Make your mark. And Mark the Caveman is back, and he says, "Make Mark big." So thank you very much.
Any questions?
Questions?